All right, it's getting a bit scarce here, more or less and less people, but they'll flock in hopefully. So let's try to keep the results of these sessions in time. We have until 3 o'clock officially, so 20 minutes, and we had 5 or 6 breakout sessions. How many do we have? So let's try to make it 3 minutes per breakout session, and then we have some buffer. I'll keep the time.
Okay, thank you, Max. So I'll try to be brief. I will give you a few outcomes of the innovation breakout session. So we had around 30 participants and lively discussions about what should be done and what could be done to foster innovation and exploitation in the flagship. The first idea that occurs was concerning the proposal that would not be selected in the ramp-up phase following the call that was held in February, and how we could avoid to lose all the ideas that are in these proposals and try to exploit this in some way or another. So it's an interesting idea. One extreme proposition was to make them available on the website. So maybe not everybody will agree with that, but there could be some intermediate situation where parts of this proposal or some of these ideas are made available in order just to keep them and to exploit them afterwards or after a certain time. So it's a question that we have to consider. Another point concerns the definition of semantics. What do we call precisely research, innovation, dissemination, and I think the common language is important in order to agree on what we are telling. Another point, a practical point, is to give access to clean rooms for external users, so that people who do not have any clean room can do their technology, which is required by their developments. Also, the flagship should focus on a few promising applications that can lead to a product or an application at the end of the flagship, which means some kind of selection of the developments. Also, it happens that many of the products or low-hanging fruits, I would say, from quantum technology can come from the academia themselves. And it should be helpful to help promoting spin-offs from academia. This connecting to the last point, which we should find ways to help and motivate people from academia to launch their own startup, to develop the ideas that come from their own research. Another point on the other side, from the industrial side, it would be useful to involve the customers in the definition of the needs that are given by the industry, so that the product really coincide with a useful product at the end. There was also a question concerning the influencing the selection process and the definition of the call by the European Commission, because it's at the time it's mostly decided by the Commission, and it could be useful to have more influence on the structure and how it works. Also, and last point is to identify incubators or venture capital that could help startups to develop and to develop their business. And those are the main lines of these discussions.
So just continue what I have next on the computer. Let's see. Nothing. We have that already. How about governance? Thomas?
Okay, so next is about governance. I think in our group there were more or less 20 people. We had very extended discussions. Some people didn't like really the governance structure. So I have two slides. The first slide, I just want to show you again the governance structure. And Tommaso already this morning told you about the boards, but he didn't really tell about the function of the boards. So I have just a rough list of tasks of these boards. So first, the board of funders, which is aligning the initiatives because it is consisting of one person of all the member states. They know what happens in the member states. The European Commission is the program sponsor. They are selecting the projects. They are organizing the evaluations and also doing the funding decisions. They also emit the calls. Then we have the Strategic Advisory Board, which is monitoring the progress of the flagship and proposes the strategic research agenda to the European Commission. The Strategic Advisory Board will consist more or less of 10 to 15 people, which are experts in quantum technologies, but which are not directly related to the running flagship projects. Then we have here on the bottom of the slide, next is the Science and Engineering Board. This is basically a representative of all the flagship projects. People which know exactly about the flagship projects, they can coordinate all these activities and they can identify, among other things, collaboration opportunities. Then there is the coordination and support action here in the bottom, which has a lot of tasks, which is supporting a lot of these other different boards. For instance, enable networking of stakeholders, layers with other quantum technology initiatives, national ones or also transnational ones. Then there is a communication platform, a web portal, which will be managed by the CSA, also information repositories about the major players in the field. It organizes workshops, conferences, it does promotion, dissemination, outreach, and it also identifies education and training needs. Then there's the Quantum Community Network, which is representing the quantum technology community, which is one well-renowned quantum technology expert per member state. And the role is to build an entry point to the different member states, help coordinate interaction and program harmonization. So this is on a very high level, basically the task list. And here is the result of our discussion. So the first point was that it is called a flagship, but actually it's pretty different from the flagships that exist right now. So this is not a core project, but it's a series of calls which are open to competition. One of the center hubs is a strategic research agenda, which is community-backed, so it grows out of the community. And then there is the European Commission Quantum Technology Units, which launches calls and organizes also the evaluation. So these are the main differences to the already running other flagships. Then another point which should be highlighted is that this structure proposal here is intended for the ramp-up phase, which are running inside of framework program Horizon 2020, and it will definitely change somehow for framework program 9. Then another thing, important thing is that it is open to the whole community, so it's not a closed shop. Everybody is invited to the community meetings, as we did so far. And we also focus to involve also other disciplines and very important industry. Then the CSA provides services to all boards and actors of the flagship. And as I said already, the members of the strategic advisory boards must not be project status. Oh, I think I have to finish, and this is what I do now. Thank you.
Okay, so this is the report of, these are actually the wrong slides. Did I send those to you? That was wrong. Those were not the summary slides. Let me send you the summary slides and somebody else.
We'll continue with somebody else. Rogier, would you like to? Improvising. Okay, I'll set you up. Halimi.
Okay, to fill the time. We had a good discussion, quite a lively discussion. Large group of people. We discussed the deltas we felt appropriate compared to the documents already in place. So the points here are not necessarily the most important, but there are the topics that people felt were not complete or not accurately defined in the current document, version, what is it, 0.1. Quite a discussion on nanofabrication facilities, not surprising. I think there was the main points were it's more than just the bare wafers, it's also about packaging and that kind of technologies that can most small groups not do at home. We need the facilities at two levels, both at the academic level for creative processes and more on the foundry or RTO level for the next generation. Some people asked foundries or the RTOs to be clear on their position. So if you provide a service to an SME, you should not compete with that SME with your own product. Well, it's quite obvious, but apparently it was not clear yet. And investments are not just a one-time investment, but you also have to maintain and update these facilities, so you also need budget for that. We had a few people from the Metrology Institute. That was valuable information on standardization, how to organize this. Of course, there is quite a good organized Euronet network. We should make use of it and not reinvent the wheel. And make sure that this kind of standardization or qualifications are accepted throughout Europe and not per nation. Innovation centers were mentioned as a good hub for startups or small companies that do not have all the facilities themselves, and also helps a lot for education. Communication networks, well, to be frank, it's quite a costly investment to build these test networks, and the possibilities are not equal distributed over Europe. Some countries already have some infrastructure that we can build upon, others don't. So we have to figure out a way to organize in an efficient way and not to invest more than necessary. A long-term ambition could be then a network to between all capitals, good pan-European goal, but it clearly shows you the traditional European versus national responsibilities and budgets. That's probably not just true for this topic. Photonics platforms were suggested as a good example on how to deal with a small-scale manufacturing. In the photonic community, we have these multi-process project wafers, etc. A few types of materials, etc. were mentioned. So we should look into this photonics environment, what we can learn from that. Communication and time frequency transfer, or the metrology people, we discussed that they could make use of similar facilities. And probably that's a more general remark. We have to make sure that we don't overdo and create facilities per pillar, but quite a few topics can be used across pillars or even with other technologies. Well, having said that, two general remarks. For example, these nanofabrications or the materials, we could think of a workshop on how to organize it in more detail, because this is all too quick and dirty, of course. And the last point was an interesting one. Now, it's nice to have this list of requirements or needs of this community, but now we need a process to prioritize, because we cannot do all of this in the first year of the flagship. So we have to think of a process to do so. That's it in 3 minutes.
Okay, now with the correct slides. This is about the training, education and outreach breakout session. And it had first a presentation about the activities that are planned during the timing of QSA. There's 2 things. We are helping to organize the Vienna event that Tommaso has already mentioned this morning. And let me repeat, one thing we are looking for still is something tangible, a physical object that is illustrative of quantum science, and we would help you installing it there, and it would become famous. We already have a few candidates, but if you have another one, let me know. The second thing is that we need to understand that education is much more country-specific and local than research. Now, we will, in QSA, mostly try to collect data and input on what works well in outreach, what works well in training, where do we already have dedicated programs, and we will poll by email and through the website the national representatives of the Quantum Community Network, as well as you individually, so help us finding the right people. We really don't know them, and oftentimes the people who are most visible in research and the people who are doing the most spectacular training are not the same people. And we can take it from there after you made the introduction. But that is extremely crucial because specifically education and training is a topic that really should bring all of us from all countries of the European Union here. So that was on the left column of the slide that appears. I accidentally previously sent the wrong slides. And I can just continue talking. By telling an anecdote, which is always the right thing this morning, because something second happened, is that a while ago, so we, as you have seen last week, Max sent you a pre-wiring document, this white paper on supporting quantum technologies beyond Horizon 2020, which in the end has an education section which looked relatively elaborate. And you may have wondered, where did this come from? Well, the first thing is that it's great to be in charge of education because people send you fantastic ideas, and most of them we could not realize in QSA because of lack of time and money. So I had a huge collection of pieces. And then I went to the APS March meeting. So some of you may know this. If you're college metaphysicists, you've probably been there. It's a conference with more than 10,000 participants. It has between 60 and 70 parallel sessions. And it's totally crazy. And this year it was in Los Angeles, 9 time zones away. Wednesday morning, I was sleeping. My phone was silenced as it should be, but it was connected to my smartwatch, which tracks my sleep or lack thereof. And at 4 a.m., the smartwatch starts vibrating, and it says Tommaso Calarco. And you know when you are asleep, I can tell, I go on, you have these inner monologues. And my first one was, probably Tommaso doesn't know that I'm in California. No, I have canceled 2 telcos with him. It rings again. Tommaso is calling again. It can't be that important. No, if Tommaso calls, it's always important. Third attempt, the telephone next to my bed is ringing. And Tommaso, being very resourceful, has called my secretary. She looked into my calendar, and my secretary told him the name of my hotel, and he called me in my room. So 20 minutes had gone. It's like 4:30 now, and he tells me the following thing. The European Commission is considering to make a significant investment, they are exploring if they wanted to make a significant investment on top in education for quantum technology, would there be anything they could spend the money on? And we need this by 5 p.m. Brussels time, which is 8 a.m. in Los Angeles. In that moment, I was awake. And I went onto a common document of a famous collaboration online service. And in how we wrote this, Max and I even considered how we write this in the best way by the fact who types faster. By the way, that's me. So we wrote a education white paper simply to be in time for these deliberations. And the goal of the consultation that's happening now is to focus, prioritize, and potentially correct it. So what's in this education white paper, you may ask? Well, it's on the right column of the slide. I'm really sorry for... I have obviously participated in accidentally crashing your computer by first sending you the wrong slide. So what's in this education white paper, you may ask? Well, it is, of course, structured in terms of target audiences. And the one that is probably easiest for us to think of, because to start with easy things, is the researchers of tomorrow, graduate students, master students, PhD students. So there we already have dedicated programs. It's important, I think, that they talk to each other, that they coordinate, and that new dedicated programs can learn from their experience and don't repeat mistakes of the past. So this is calling for some coordination effort. Now, my memory is probably getting a bit incoherent because I'm talking about guide for a minute, but secondly, we need to go in the full geography. So what do we do with people who are in small centers who cannot pull off a full dedicated programs? What we propose there is, first of all, networking makes it easier to get credits for Erasmus-type systems in institutions somewhere else. Secondly, we feel that there is a great need for materials that can be studied online, that, for example, can include videos. If you want to have a lot of YouTube hits, lecture on quantum computing, it gets you a lot of interaction that could at some point actually be developed on a 10-year perspective into massively open online courses, MOOCs, that you can then also take for credit. So if you're in a place that has, for example, great mathematical physics, you can also learn something about engineering. And I will have to finish. So we then have looked at how to reach out beyond these traditional audiences, specifically teachers as multipliers, engineers, non-physics majors. For this, we have identified it as important to get the dialogue going and to also get education researchers involved. Thirdly, I just make a quick bullet point list out of my head here. Thirdly, we thought it would be great to have hands-on material, so to find a way to sponsor that renovations of education laboratories contain good experiments about quantum technologies. And I think that can be done kind of during a renovation cycle, but on a higher level to also invest in larger platforms. In the discussion, it was pointed out that we need to be careful how to implement this, to not do it too much top-down, to not have too much overhead, because education remains to be the pride of universities and the pride of nations. But still, it was identified to be useful to have extra means and extra resources. And now I'm looking at Lydia, whether I seriously, who took the notes, whether I seriously forgot something of the discussion. And we need to have it all closely networked, and we need to be able to spread things out broadly. And specifically for reaching out to engineers, to make it possible for engineers to do sabbaticals in research organizations, to consider having a professional master's degree, but mostly also to get the dialogue going and to educate engineers and physicists as much as possible together. I am sorry for the slide mess. I can take questions, but not right now on the stage. Please contact me if you have them.
Okay, so my session was about quantum technology in space. Before, just a very quick announcement. So it was supported by COST, through the Cost Action Security Space. Several people applied for funding. Thank you, but if you do not sign the attendance list, you will not get funding back. So Matteo in the back has the attendance list. Those of you who didn't sign it and applied for money need to sign it now, otherwise no reimbursement. Okay, so I have a couple of rather technical, hope you don't be scared. It was a very successful session with about 35 people, very interesting discussion. And the topic of quantum technology in space is divided into two parts: quantum science and quantum technology in space. Quantum science means doing, so it's basic science, testing quantum physics in space, or using quantum physics for other tests in space. And you see, for example, tests in entanglement and space-time models through photons, or tests of general relativity and the quantum gravity interplay, testing gravitational waves in different regimes, of course, with respect to LIGO and LISA, tests of quantum coherence. So it's fundamental physics, our understanding of nature. I will not say much more about that. There are all the details there. And you see that there is quantum is difficult, of course, because you have to control the degrees of freedom. Space is difficult. Quantum in space is very much difficult and very much costly. I just sum up the money that the figures that people gave me, it's already half of the size of the flagship just for quantum in space. So the quantum program in space cannot be part of the quantum technology flagship. It needs to be much bigger than that if it wants to be really ambitious. Of course, we speak about a 3-year horizon, a 10-year horizon. 3 years is tomorrow, 10 years is tomorrow plus 1 minute for space. It takes a lot of time, but that's the horizon so far. Regarding quantum technology, these are the vision and the societal benefits. So it's about secure communication. This is a key ingredient for the world, for Europe in particular, how to deliver more secure channels of communication. Optical quantum communication promised to do the job. It's a very long process. So of course there is a quantum communication in space. We are interested in quantum on Earth. Sorry, we are interested about quantum communication in space. So through satellites, everything more ambitious, more challenging, and more important in that sense. Or understanding climate changes, precise navigation, Earth and planetary observation. You need good sensors. So there was a lot of talking about sensors in all sessions. And atom clocks and cold atoms provide very precise sensors for measuring time and frequency with higher precision, or measuring force differences, in particular gravity differences, with very high precision. And then you can do a lot of things. Map the Earth, map the evolution of oceans, for example, do better navigation on Earth, but also deep space navigation. Why not? And a provisionary budget for 3 or 10 years, you see the price was even higher than before. That was also, we have improved, and you will find it online. You will find it online if you go on the QT Space website, strategic report, you can download it, you can comment on that, and you can leave us a feedback. Thank you very much.
Yes?
One question. According to what Tommaso said this morning, who pays the bill?
Who pays the bill? So, let's see if it goes back. So I limit to technology because probably... Okay, no time for going back. So there was, the bill has to be paid partly by the national agency, partly by the industry, because there is a lot of technology development. But I guess that most of it, since it's a societal benefit, has to come from Europe, from the taxpayers at the end of the day, my impression, in the long run. Yeah.
Maybe we can think about, discuss about international cooperation. Maybe we can think about space using ESA, the JAXA, and also NASA, and so to make something much more international for this.
I mean, as a scientist, I would be very much happy about that. Of course, there are. So to go beyond Europe, if I understand correctly, involve NASA and other countries. Of course, I mean, as a scientist, I like a peaceful, happy world. Then politics comes and many other things. Hopefully, that will happen. It's difficult. It is.
For science in space, I think
for science in space, no, it's probably very much possible. For technology development, there are a lot of things to consider.
Thank you.
Thank you very much.
One last session on the session on international cooperation. I have your thing here. Yes. So.
Okay, thank you very much. Good afternoon. I'm Sylvia Kostka from Quantera, and I had the pleasure to moderate discussion on international cooperation with very prominent panelists from Japan, so Professor Arakawa, Professor Okmori, and Dr. Ueda from the US, Professor Gillespie, Dr. Kramer, and Professor Liebfried, and as well from the European Commission, Dr. Ali Benmoussa. So we've discussed the benefits and challenges in potential intercontinental cooperation. The big question was, do we share the same vision, as you can see here? And actually, what Japan and USA said is that we are at the very preliminary stage, pre-competitive fundamental science, whereas Europe find basic research pretty narrow to technology, and there the challenges comes from. So all of us, Japan, US, and the EU, we have big national investments in quantum. So what about potential cooperation? So as usually, the devil lies is in the details. So it means that what we need is more communication, effective communication through workshops, for example. And what we need as well is to find a win-win scenario, so all sides could be happy with the cooperation. Anybody would like to comment on this? I have just 2 minutes. I have just 2 minutes, so that's why I'm speaking so fast. Anyone? No? Okay, so as at the very end we decided that effective communication is the basis for our future cooperation, I'd like to thank Professor Tomako for putting the stepstone, the cornerstone for this cooperation. Okay, thank you very much.
And thank you for sticking to the time. So, and sorry again for the mess. So we are. So I think we'll do it this way around. Ali, you told me before you have a 15-minute slot, but you can do it in 10. So maybe you can also do it in 8. Yeah.
Okay, so my name is Ali Benmoussa. I joined the European Commission just recently, 6 months ago. So I was requested to give you a broad overview of the Quantum Flagship, but well, okay, I will just try to also to focus mainly on what we are doing this week on the evaluation of the first call, what we call the roadmap phase. So just one word to say that, and this is a word that you will hear a lot, mission-oriented. So this is a kind of top word now to express the fact that for this particular quantum technology flagship, we would like to bring really labs result to the market. And this is a little bit what we call mission-oriented with this added value for society. But what we're also working is also to make a critical mass, and this is what we call quantum technology ecosystem, at least European level, and this is what I will try to show you. So rapidly, a timeline for the next following years. So we are now in this what we call roadmap phase. So it's the only call that we will have until the next framework, which is FP9. So I just wanted to rapidly give you what is this roadmap phase. So it's it will be funded until under this Horizon 2020 work program, and it follows what we call the strategic research agenda, meaning that it has defined different subtopics that I'm sure that you are all aware about this. And so we have around 130 million euros for these topics and 2 million euros for next coordinated and supervision, knowing that right now there is one which is held by lead by Ulm until next year. So just some numbers about this roadmap phase. So we receive 140 proposals. Here I put the topics A, B, C, D, which is communication, computing, simulation, and this E topics is this basic science. So as you can see, we receive, I will say, little proposal on the A, B, and C, much more, twice more for metrology and sensing topics. And for this fundamental science, we receive 90 proposals, which is quite a lot. As you can see, the requested budget doesn't fit our allocated budget, but at least we will have 110 million for topics A to D, knowing also that at least 2 proposals for each topic will be funded. For E, we have up to 20 million, but those proposals usually have a budget between 2 and 3 million, while for A to D, we receive a proposal up to 10 million euros. And from the CSA, you can see there's also a mismatch between what it was requested. So we have only one proposal. So They request 3.5 million. We have only 2, so I believe there will be a negotiation phase in the near future. Some other numbers. So we receive, maybe this one, just to show you that which countries are really involved in those calls. You can see that Germany, France, and UK are quite well represented. So more than 400 partners. What is nice in topics A to D is that we are 30% of industry, which is quite high. Unfortunately, you can see the gender balance. We are only 12% of coordinator, but it's quite, from a point of view, it's not so bad. I was expecting even lower, but so it's something that we will have to improve, of course, in the future. And also, we have a nice participation of different countries, EU, of course, but also from non-European countries like South Korea, South Africa, and so on. And this is the rapid time scale of the following months. So we expect, so right now we are doing the evaluation. We finished the A to D topics, and next week we will start this fundamental science evaluation. And even if I'm not allowed to say, I really had a very, very good proposal. So there are many proposals with the top score, so it will be very tricky to select which one will be fundamental. So we expect the result by first week of June, and hopefully the project will start before the end of the year. Rapidly, I will just introduce you the next call, which is cybersecurity. It's about a QKD test bed. So this date was just updated. So the opening should happen in July and closing in November. And in parallel to this QKD, I would say ground test bed, there are also, maybe you discussed this during the quantum space, there's also parallel development in in-orbit demonstration, like this Skylight program, but there are also other one on the Galileo, which are still preliminary, but what's to say. So this is a very broad picture. So I put the Quantum Flagship in the center, which should be coordinated by this quantum, which is already started to be coordinated by the quantum support and coordinated detection. And all around, you can see there are other also initiative like Eramet, who just finished the evaluation in November, and they will start a new project on this, on quantum. Cost action, Quantera 1, there is a Quantera 2 also with probably 50 million. This ESA Skylight and so on, and this QKD test bed. So at least at our level, at the European Commission, we try to coordinate all this with the help, of course, of you, of the community. And okay, to raise these critical mass that are needed to reach our objectives. The next one, the full implementation will start after 2020. And to be honest, here we are still on the negotiation phase. I mean, not me, because at my level I don't have any power, but the high-level commissioner and so on, they are really fighting for the next annual financial program. We should receive some report in May, as I understood, and under FP9, so the next framework program, we expect something in June. So here, for sure, the quantum technology will be pushed as a mission. We have other financial resources for other activity in infrastructure, skill, and application, like in cyber securities. We plan to have some infrastructure in quantum communication, but also in quantum computing. But this is still under negotiation, and so I have unfortunately, not so much information for that. That's it. Question?
I would like to understand about so I've heard several times, and also now that like the calls are over, and now now we are waiting for the next framework. So I'm a little bit lost because there's 132 million and we have 2 billion. Like there is some mismatch. So, when other calls are coming, are they coming at all? I'm a little bit lost.
So we are here. Let me show you. Yes, we are here in this rollout phase. So this phase is really to start coordinating to make the community together. And so for this, we take the traditional call, so putting 130 million and trying to generate consortium around Europe and to start to work. So we, of course, even if you expect from those calls to bring some real market project, the idea is really to coordinate the community. And so this rollout phase, yes, the duration is 3 years or 4 years, it depends on the project. Ideally, the whole project should finish in the same, but I know that some projects ask for 3 years, some other for 4 years. And yes, during this period, there is not other than the cyber security call. There is no other. We are working here with money of Horizon 2020, which will finish in 2020. So now we are already working on the next step, so requesting much more money. But since we don't have the assurance that this money will be available, so we cannot launch anything right now. So what is also that doesn't appear here is that usually at the end of this FP8, which is Horizon 2020, there's still money left because not all other calls have used their money. And so there are some missing, there's some available budget, and for this we are also expecting something to probably to launch some other call if this money is. I thought that you wanted to make some early, I forget what was about education things, and you are thinking about to give a prize for young researchers. So, and this money available could be used to make a prize in the quantum technology for young researchers, such kind of example.
I know there are probably many more questions, but we have to cut it here, unfortunately. Ali will be around still a couple more minutes after the symposium, or maybe even a bit more minutes. So please ask him then directly. I'd like now to have the panelists take the stage.
Just a little bit of confusion. So now let's get serious. The final panel discussion. For that, I would like to ask on stage, first of all, Jürgen Lüneck, the head of the high-level steering committee, and in a way the pivot point of any quantum activity here in Europe, I'd say. A second, Alain Aspect. According to Wikipedia, a French physicist noted for his experimental work on quantum entanglement. According to my memory, a perfect representation of the entanglement of personality and quantum technology. Welcome on stage, please. Then we have Tommaso Carlacco, the captain of the Quantum Flagship. And maybe in future, or maybe not, the admiral of the Quantum Fleet. Then we have Walter Ries, department head of science and technology of IBM Rüschlikon. He manages the quantum technology group of IBM in Rüschlikon. And what I found out in the meantime, he argues as crisp as a computer calculates, a quantum computer. And last but not least, Jürgen Gross, Senior Vice President of Bosch Corporate Research. He has a strong quantum technology past. And what is most important for this discussion, he has an expertise of 10 years hardcore product development before moving back to research. So he knows how painstaking it is to bring a product to the market. So, welcome. By the way, my name is Michael Totzek. I'm a fellow here at Zeiss. And when Tomaszo asked me to have here to lead this panel discussion, I said, sorry, no way. I don't neither know the politics of the EU, nor do I know the politics here of the Quantum Flagship. And then he told me, Michael, that is exactly the reason why we want to have you here. So please forgive any maybe stupid or unpolitical questions. Maybe that is my task to ask them. So, but first of all, Tomaszo, I like very much your image of a kind of this quantum flagship, quantum fleet, a kind of a journey. An important part in a journey, if you enter the next stage, is a short look back. So just from the first phase of the quantum flagship, what is your main learning of it?
Well, personally, my main learning of it is this is only coming together based on a very broad involvement, a really pan-European effort, which implies, a broad community in each of the member states. This is how this can thrive, and this is how this is going to thrive also in the future.
What about cooperation, in particular of science and industry? In this quantum flagship, how did it work so far?
I would say that. Oh, is it for you or for someone else?
Sorry, maybe Jürgen Lüneck. Would be cool to get your answer on that.
Well, maybe you better ask also our representatives from the.
They will be asked second. No reason, just.
All I can say is that in this one-year discussion that we had in the high-level steering committee, where we had 12 representatives from the private sector, from companies like Bosch, for example, and others, small, medium-sized companies, large companies, startups, and from academia, there was no controversy on the flagship goals. And I think this was really, I wouldn't say a surprise, but this was a good discussion ground to come up with a report. And this is something I guess we have to come back to. This flagship initiative is not just additional money for what people already do. There must be an added value, and this added value must be clearly related to wealth creation. And there was agreement, to my surprise, also within the academic community to go for it. So it worked.
Cool. Then Jürgen Ross, the other Jürgen maybe, to comment on that, your perspective.
Well, I wouldn't be so bold to say you never can do better, but I would also stick with the statement we do already quite well if we compare it to other instances. I think we established a good cooperation, and I'm personally, and we as a company are deeply convinced that only by intense cooperation between academia and industry, we can make this challenge happen, and we can really progress on the things ahead of us. So I'm happy that I can confirm that they basically.
But then maybe just looking forward and in retrospective here, the discussions we had here, there have been quite some discussions about bottom-up approaches or top-down approaches in moving forward. So shall we define certain challenges like the DARPA, certain based on the missions, for instance, or should we have something like a bottom-up approach from the technology? Or shall we use a kind of a matrix approach? What is your finding here based from these discussions we had so far? For me, there seems to be no real consensus here, and I would like to get your opinion. Maybe, Walter, your point.
Okay, so first of all, perhaps the first comment also to how we feel this system or how we are embedded in this project. The nice thing is we are actually in the middle, because we are a research institution, so we are actually very well linked with academia. But of course, what we like from this flagship initiative, this leads, and this was also on one of the slides which we showed earlier, that this is the drive from science to technology, and actually as a company research center, this actually is perfectly in line. Having said this, and this is now the thing, and I think we are talking about the next phase of this flagship. How should we structure this? How should we, let's say, make the structure in such a way that it is successful? I am actually a fan of goal-oriented. I like it really very goal-oriented, and also as a company, we are also used to make a very broad approach at the beginning for a new technology. For example, if we're looking in new technologies for phase change, we are looking into resistive RAM, we are looking into ferroelectrics, we are looking into various approaches. But at the end of the day, there is a certain timeline, and then we make a decision. And this make a decision, this does not mean that we abandon everything completely, but we focus. We are putting spearheads in certain directions, and because we do not have the money, we do not have the resources, and I think in that respect, this would also be a very good instrument for the second phase to put a certain focus level on, and this was also what we had discussed together with, this was on our slides which we presented. Be a bit focus-oriented, be focused, be goal-oriented.
Okay, Alain, in particular on this approach to being focused.
Yeah. Well, first, I'm talking for basic science and fundamentally basic science, especially in the academic world, has no goal other than doing what you like. Okay, so I'm strongly in favor of this bottom-up approach. That is to say, let the people decide on what they want to do. And we had a list this morning, but this list is not intended as a list that we would impose on the people. It's just the opposite. It's the people in the room who say, oh, this is interesting, that is interesting. And I think that's the way basic science is working. And I'm deeply convinced that we should not play the roles that we do not know how to play. In other words, if you ask people working in basic science to pretend they can do like the company people can do, it will be a failure, okay? We have to keep in our role. One thing we have to ask, in my opinion, the people in basic science is awareness. Awareness that what they do might be useful for something. And if they think it might be useful for something, then they should go and talk to the people in companies and say, don't you think that what I am doing might be useful for something? This is very important. Remember that there was a time when people in academia would not even do that. They would not cross the street. I speak on purpose, I am across the street from Thales. There was a time when people would not even cross the street to say, you know, you should come and see what I have in my lab because maybe it may be good for you. So what I defend is the idea that people who are in basic science can do what they want, okay? But they must be aware that if they think of something, they have to propagate it. And for this, of course, the flagship and the various instances, the flagship are ideal because I am in favor of forcing the people to talk to each other.
I think this this talking of the people to each other, that is one of the major things and topics we are trying to do here. And the intensity of the discussion shows a little bit that this is quite complicated between goal-oriented and really curiosity-oriented. Any further comments or ideas how to improve that we get forward here?
I think what I'm now saying is not in contradiction to what Alain said.
It could be.
But for me, the flagship initiative is clearly a strategic initiative. And of course, there is a certain amount of money for this more basic science approach with maybe completely new ideas on each of these, various areas like computation and so on. And I'm saying this because we have to be aware of our competitors. The Chinese have a master plan and they are not money limited. They are not money limited. And the US is also not money limited, especially with respect to companies. If Google or Microsoft is burning a couple of hundred of millions of dollars, nobody cares. So that's the situation. And if we as Europeans do not get our act together in terms of pursuing in the flagship strategic goals, we will not be able to really compete at the global level. We have the European Research Council for basic research at the European level. And so far, we didn't speak about contributions from the member states. We hear about this trucks full of money from Brussels. I always say the future is always bright. Nobody knows. That's one thing. The other thing is, what will the member states do? And here again, we have to make sure that contributions from the member states somehow fit into the overall picture, because otherwise it doesn't make sense either. So we need the right combination of strategic approaches and this more basic science approach, but for me, overall, it's clearly strategic.
Even if you have strategic goals, there are still some low-hanging fruits that you can harness in order to really produce just first successes. Shouldn't that also be a way forward? To harness first of all these? For instance, in terms of sensors, like we had yesterday. Maybe,
I think this
Thomas.
is an example of what I wanted to say in a sense, because in the segment of this video that I showed this morning, before the segment I showed, Bill Phillips was asked a very similar question between, should it be top-down or bottom-up? It was related, not exactly this question. And he said, let me give you a quantum answer. We need both. And to me, it is pretty obvious that, and this is the relationship between those two answers, that if you had the people just doing whatever they please, bottom-up, and disconnected to some strategy, this is leading nowhere. As much as if we had a strategy which is disconnected completely from what is really happening in the labs and in companies, that leads nowhere. And a superposition of both strategies means that when you define the overall strategy, you have a very strong input from below, but you are not just limited to that, you are encompassing this into some common goals. And, I see this happen here. I see the intense debate, but it is through the intense debate that this is happening, and this is the only way which I see in which this can be successful, and in which not only the community in terms of people wanting to do what they want, but also the society in terms of the goals we want to achieve can thrive. This is exactly what I meant before. And this is what you mentioned, like sensing low-hanging fruits, is something which is within reach. It developed in labs. Of course, we have goals in mind, and then we connect. So it's about connecting things.
Alain, you wanted to react?
Yes, or is not react, is to comment. As Jürgen said, there is no opposition. The value of the flagship is that it is not only goal-oriented. There is also room for basic research, but as I said, if basic research, for instance, you mentioned ERC. When you get an ERC grant, you don't care very much about application. While if you get money for basic science in the flagship, you are aware that if you could do something for application in the flagship, it would be good. So I think this is extremely important.
I must admit, I like it. I like the complete approach here, just to have this infrastructure approach, space, healthcare probably, and then really the combination with basic tasks. But just from experience, the combination and just to get to an agreement finally, to make it overlap and match, is not an easy part.
And perhaps one side comment, of course, the flagship has a mission, and hopefully will at the second phase goal-oriented. But I mean this goal-oriented means similar like a hike in the Swiss mountains. If you would like to climb up these mountains and you climb along, this means you should definitely, if on this tour you see a better mountain where you have to climb up, you should never take this one. It does not hinder you from innovation on this path. But the goal is to move up. If you go higher, this is in your hand.
Okay, so maybe I'm basically in line with most things that had been said, maybe rephrasing the strategic aspect in the sense that there is a taxpayer in Europe and the taxpayer gives a lot of money into an initiative. And I think we have to give something back which is strategic in the dimension, and it's not only the growth of understanding in science, that would not be enough for me. A low-hanging fruit could pay into that basket, but 2, 3 low-hanging fruits wouldn't be strategic. So we have to come up with something tangible by the taxpayer, that the man in the street, not having a background in quantum physics, understands how this contributes to make society a better place. And that's mission-oriented. And I think we have to work on that because we haven't sketched so far what's the deliverable. I think we are on the same page. That's my feeling, that we have to come up with something. But the next step would be to really be a little more specific on what that something could be. And if we find on the way that there is something even more beautiful, we are free to change, but we shouldn't end up a 6 year period not having something.
There's one other aspect that I would like to bring up here. I think within the flagship, we need also some, I wouldn't say, change of mindset, but it's not enough to produce nature and science papers. I think the engineer and first-rate letters and applied physics letters, okay, and so forth. Okay. I think the engineering part will become very important in this flagship. I was really nervous when I heard from some of the leading groups, for example, on ion trap work in Europe, that they are supported by DARPA to make the next step from, creating ions in a trap by turning knobs to pushing a button so that the ions can do what you really like to do in terms of, exploring algorithms and so forth. That cannot be. And this was also something that I told, the funders in Germany. This was not supported by the EU. This was not supported by the national funding agency. And I must say, something is going wrong here. So what we need in terms of the flagship is, how can I say, the willingness of the scientific community to make this step. And of course, at the end, also key performance indicators, to use these words, that somehow reflect this challenge. Because if you do engineering, then maybe over a number of years, you will not be able to have a first-rate letters. Maybe after 3 years or 4 years, you can make it. But in the meantime, it's just hard engineering work. And I think this has to be a significant part of this flagship. Otherwise, we will not have, demonstrators and at the end products and technology advantages. No way. So the mindset of the academic community has to be different. And with respect to companies, Steve Jobs once, when he was speaking at the graduation at Stanford, said, "Be hungry, be foolish." And he created Apple. So I think the companies also have, I wouldn't say be a little bit more foolish, but they should be also willing to take a certain risk, more risk right now compared to our competitors, especially in the US, to invest also in, let's say, scientific developments that might lead, Walter, to technologies, but maybe fail.
This is the valley of death you're speaking about, between basic science and application. But maybe there's a different solution. Startups. So just small startups. Apple was a startup that time, founded by the universities, for instance, with European money, just to cross this valley of death until industry can take over with a more clear business model than they have when the technology has just been developed and the application is not clear yet. Is that a solution? Or different solutions?
Sorry. Yes, I think that's part of a solution, and you said it perfectly.
I think that we tried to show this type of picture. Startup is a very crucial part of this ecosystem, but it is not sufficient. I think what we need in order to create an ecosystem around this type of quantum, and I speak now only for quantum computing. First of all, you have to have access to quantum computing. This is number one. Then you have to have, so this is, you can call it as you like, call it hub, or is a provider who gives you this access. Then you have to have academic institutions who really have the deep expertise. And this was mentioned, I think, in the discussion we had. If you would like to attract industry, here you have to differentiate between the different type of industries. You have the Bosch, you have the Siemens who really look into quantum computing or into this quantum area. But there are other newcomers which are completely new. The only thing is what they would like to do, they would like to learn about this. And this means this quantum resource, together with the academic institute, together with the research institutes from governments, etc., they can provide a resource for industries to create, to be the starting point of an ecosystem. And on top of that, you can invite small and medium enterprises also to get access to this type of knowledge. And the startup is then something which comes immediately out. Here comes the important point. The universities, they need to start with a new type of studies where, what Jürgen says, the quantum engineer is a part of it. Because we need to create something. We need an engineer who understands quantum. He needs to understand that this is a fragile system. Very, very important. Then we have to have also the people who are now using, of course, they have to study math, they have to understand optimization problem, but they have to understand how they implement it into a quantum system. It's a completely different story. And having built up this ecosystem, suddenly you realize something. The people are very interested in studying, in going into this direction, because they know the big companies are interested, the small and medium companies are interested. And by the way, if I'm creative, I can create my own startup.
But don't you need to create this quantum engineers, which are admittedly really necessary here? The ecosystem already existent because you just develop these quantum engineers, so they need a job afterwards in the community. So aren't we here in a hack-end problem?
Well, I think it's not so difficult. For instance, take my institute, Institute of Optics, which has been training engineers for 1 century in optics. But as years were going on, there is more and more basic physics in their training, and I am professor there. They have courses of quantum physics, and 1/3 of them is going for PhDs. And so it means that these people are there. The question is, do we have industry ready to hire them? But we are able to educate them.
Yeah.
Maybe one remark concerning this education issue, which is, I think, very important. Let me take another example, battery research. Now, one of the problems, at least in Germany, that we have with battery research is that over many years, electrochemistry was just neglected, was not present anymore. I mean, there were a few universities in Germany that still had, shares in that direction, but essentially the field was very strongly reduced. And this means you need years to come up again with students, master students, PhDs, and so forth. We shouldn't do the same mistake in this area of, quantum and engineering. And I think the universities really should think about, as soon as possible, establishing some kind of quantum engineering studies and so forth, where we can take advantage of these wonderful talents that we have in Germany. I mean, we have extremely well-trained and capable young people in Europe. This diversity is just wonderful, and we should take advantage of it. And this starts also with the curriculum at the university. We have to train them.
So maybe taking up the point of battery research, there's also hope in the sense that it took us less than a decade to come from a situation where no trained electrochemical engineers had been offered to a point where we as industry could pick amongst the best. So that was less than a decade. And I also see already today a very good movement towards quantum technology. It's a hype topic. I'm a little concerned that we do not overhype the topic. Because there is especially, if we look across the Atlantic Ocean, there are so much promises with respect to what quantum computing can do on what time scale around that we have to avoid a big frustration that will make people walk away from the topic within a few years because nobody will see a 1 million qubits quantum computer in place. Although some people are at least, if not promising, at least they are suggesting that that could happen in a short time scale. So that's one of our concerns.
Perhaps a comment, and it's an interesting example with a battery research. Do you know how much the efficiency or the capacity of a battery went up in these 10 years?
The cost went down by a factor of 4.
The cost went down by a factor of 4, and I assume you have roughly doubled the capacity. Yes. This is what I would have expected. And in these 10 years, if you now would have projected this down to the semiconductor industry, what would have happened in these 10 years? This would be orders of magnitude different. So it depends on the industry whether you have 10 years time or not. It's very
That's a high point. Is really pretty important. I mean, you're also a Swabian company. So in Swabia, we have this saying here for our sales personnel, under promise and over deliver. I think with this kind of statement, you don't earn money from the European Union. So how to solve that?
Well,
you know the solution.
Well, I will tell now. Are we on YouTube?
Yes.
Oh. Okay, so I will sort of hide out some details. But a few years ago, actually, when this started in the beginning of the preparation for Horizon 2020, together with a very prominent colleague of ours, who is not here tonight, I was at lunch in Brussels with a very high-level representative of one of the important cabinets in the Commission. And this person told us, well, I know you are serious scientists, but could you please do a little bit of bullshitting for me? Because I need this to sell it upstairs. And upstairs was not much upstairs, because he already was upstairs. So with our colleague, we looked each other in the eyes, because normally to any normal person, we would tell them some word which would not be repeated on YouTube, and we would say goodbye. But this was someone who was in that position, so we thought, oh, what do we do? Because if we now tell them the appropriate thing which your integrity as a scientist would suggest, and your sense of responsibility would suggest, then maybe you are missing a significant number of zeros after a certain digit in euros. So what we did is almost ridiculous now. I went back home and I convened a meeting of our strategic advisory board, of our coordination action then, and we discussed for 3 hours the question, do we do bullshitting or not? And the outcome was, no, we don't, for 2 reasons. And the first one is the one that we as scientists value, which is our integrity. And the second one was what Dr. Gross said before. It is not going to help us. And we have seen it with other flagships. So, of course, it is a difficult balance to strike because you have to promise things which are exciting, but which are not over-promising. I think that when we published the Quantum Manifesto, and I had 2 colleagues, and one of them is in this room, and I will not tell the name, who said, no, I'm not signing that, because in your roadmap, point 2E is too advanced. I cannot believe in that. And some others said, point 3D, no, that's not realistic. So I had 2 people saying that. If there would be nobody saying that, and everybody would say, oh yes, of course we can do that, I would think, well, we are not really ambitious. If I would have of 4,000 people, 3,999 saying that, but if there are 2, that's just about the right number. And this manifesto has been really endorsed broadly by people who have thought about shall we endorse it, and it has been modified, taking in the best wisdom from the whole community, which is the same thing that we did this morning. So this is for me the superposition, bottom up, top down, to strike the right balance. And maybe not undersell, because after all, Brussels is not in Swabia, but just hit the right level.
Exactly, to be as exact as possible, obviously. Alain, sorry.
Yeah, I have been very concerned from the beginning about this equation of hype versus under-promising for over-delivering. And sorry for the people who already heard me, but I think it's one motto that many of you can use if you have to speak to your national policymaker, etc. I said it to the commissioners, you remember, in Brussels. I feel regarding the universal quantum computer, as I felt 30 years ago regarding detection of gravitational waves. Let me elaborate. There is no fundamental law of physics saying that it is impossible. But the technological gap seems absolutely unbelievably large. And that's all. And I say, I cannot tell you more. It may be 30 years, it may be 10, it may be 50, who knows? It may be never. But, and then I add, but of course, between the universal quantum computer and nothing, there is all the series of achievements that we are going to deliver for sure. So I think this corresponds to your demand, okay?
That's a nice example, but also not completely correct in the sense that in terms of optical interferometers, starting with, the early days of optics, you could say we gain 1 order of magnitude every 10 years. So there was some kind of scaling law. And if you really think about it, that's what happened when the first detection took place. In the case of quantum computing, it's really different. And that's the challenge. So I would say we have to be ambitious, not too ambitious, but we have to have a challenge. And we should pick it up.
And by the way, you're here at Zeiss, so EUV lithography was basically just the same 25 years ago. We had many people saying, heck, utterly impossible. Thousands of a wavelengths accuracy at 13.5 nanometers, forget it. And now you can buy these things if you have a little bit of money.
So thanks for your remark, and I'm totally in line with your statement. There is no fundamental law that prohibits a universal quantum computer. But we have to improve by significantly more than 1 order of magnitude. That's also to keep in mind. So it would be a wise idea to find out the scaling law for that one. If we know it, we might be able to have better predictions. So I don't have it, but I think it would be worthwhile a discussion. One aspect from my point of view, and that's typical for discussions on quantum technology, that we snap into the quantum computer quite quickly. And I just want to come back to the point where we have many pillars in a quantum technology field, and the first results, the first positive findings, and the first proofs of principles might not be in the area of quantum computing. So they might be in different areas. So we shouldn't put all emphasis on quantum computing.
Absolutely agree. And I get signs here that our time is a little bit over. And when I have a look at my notes here, the discussion went a completely different road than anticipated here as a real project.
Those questions going to come, because you told me what you would ask.
I'm very sorry. I was listening in the community as you are listening in the quantum community and try to mitigate what I'm hearing and try to make the best out of it. So I hope you enjoyed. I enjoyed very much. Thank you very much for this discussion. And yeah, maybe some applause for our audience. And with that, we are coming to the farewell session. And before I give the microphone to Marshall, just a little farewell here from Zeiss to tell you, yeah,